Hi, my name is Sean. I'm studying at UCLA and my major is psychobiology. I'm interested in tutoring IB chemistry and biology as well as GCSE science. I've tutored in the past in Hong Kong at a tutoring center. I've tutored IB chemistry, biology, as well as some IB math and some GCSE science. I've also done some private tutoring for flute lessons over Skype. Okay, so today we're going to be talking about topic 4 of IB chemistry, which is molecular shapes and bonding. Specifically, I'm going to be teaching you about valence shell electron pair repulsion, which is what the VSEPR represents here at the top. Now, first, some terms I need to define, BP and LP. So BP stands for bonding pair and LP stands for a lone pair. A bonding pair is when two electrons are shared between two atoms and are responsible for a bond, like a covalent or an ionic bond. And a lone pair is two electrons that only belong to a single atom and are not used for any kind of bonding. Okay, so we start off with a simple shape with two bonding pairs and 0 lone pairs. And the result of this is that we get this kind of straight shape. And the dots here represent the atoms and the lines represent the bonds between them. So this is called a linear shape. And when we're asked about bond angles on the test, we're asked to identify this angle that I just marked down. So in this case, this angle is 180 degrees. So between the two bonding pairs here, there's an angle of 180 degrees. So onto some more complicated shapes with 3 bonding pairs and 0 lone pairs. The resultant shape is something like this. And it's named accordingly as Trigonal Planar, named after its shape like a triangle, trigonal. And also all of the bonding pairs are on the same plane. So that's why it's called a planar. And the angle of this is 120 degrees. You can tell if we look at this little circle, if we draw a little circle around all the bonding pairs and divide it by 3, that's a circle divided by 3. So 360 divided by 3 is 120. Okay, next is a very important shape that will come up a lot. And this is when we have 4 bonding pairs and 0 lone pairs. The resultant shape we need to draw in 3D. So I'm going to use some wedges here to indicate that this atom is sticking out and out that way, that way. So this is a 3D molecule. These shapes show that it's protruding out from the screen and this is going back into the screen. So this is called the tetrahedral shape. Tetrahedral. And although it may not look like all of these molecules are spaced evenly apart, if we take a 3D model, you would actually see that they are symmetrical around the central atom. And the angle we have here is 109.5 degrees. Okay, so now we examine what happens if we substitute a lone pair for a bonding pair, a bonding pair for a lone pair. So if we take 3 bonding pairs and 1 lone pair, that's essentially taking what we had last with the tetrahedral, except substituting one of the bonding pairs for a lone pair. What we get here is a shape like this. I'm using the 2 dots there to represent a lone pair over here. And what happens is that since the lone pairs are more concentrated together than the bonding pairs, since the bonding pairs have to be spread out between 2 atoms, but the lone pair remains on a single atom, that means that the charge is more concentrated around the lone pair than the bonding pair. So that means it will repel the bonding pairs more. Since all electrons are negatively charged, the concentrated lone pair has more repulsive force than the bonding pair. And then this happens and we get a smaller angle. And this shape is called Trigonal Pyramidal. So it's shaped like a pyramid and it has 3 sides. And the reason why the angle is shorter is because of what I told you, is that the lone pairs repel more than the bonding pair. And because of this, the bonding pairs are pushed closer to each other than in the tetrahedral shape, resulting in a smaller angle over here compared to what we had over here on the top. Okay, so another example of this is if we take away another bonding pair and add in another lone pair. So now we have 2 bonding pairs and 2 lone pairs. And resulting shape here looks something like this. This is called a bent or a V-shaped. Okay. Add in that there. Okay, so this shape, once again, it has an even smaller angle. And this is because of the same concept we discussed above, because we have an extra lone pair here instead of a bonding pair, which means that the repulsion is even greater than before, which pushes these 2 remaining bonding pairs closer together. And therefore, we have a smaller angle here as compared to the previous ones. Okay. And that's pretty much it for all of the angles and shapes that you would have to know as a standard level student. There are some more for a higher level, but we won't go over it today. Thank you.